Let us try to understand what is meant by set false path. So this is one of the Synopsys Design Constraint which is used to set false path. So all the timing paths which designers know won't be exercised on the fly and they don't really need to meet any timing constraints on that path can be marked as false path. Tools would compute delays on all arcs on the false path, would try to meet slope, max fanout, max capacitance targets for all nodes along the path, but these paths would never surface up as timing violations. So here timing violations are nothing but setup and hold violations. However, if designers are too concerned about meeting slope and max cap targets, they usually prefer to mark such paths as multi-cycle paths. So this is one of the timing exception, and set false path is also one of the timing exception. Set false path is used to instruct design compiler or else Genus to ignore a particular path for timing or optimization. Here DC is design compiler from Synopsys and Genus is from Cadence. So these are the two tools that we use for synthesis. Identification of false path in a design is critical. Failure to do so compels DC or Genus to optimize all paths in order to reduce total negative slack. Here total negative slack is nothing but summation of all worst negative slack. Consequently, the critical timing paths may be adversely affected due to optimization of all the paths which would include the false path. So here critical timing path is something which will have more delay. So this is the path which is having highest delay among all. The valid start point and end point to be used for this command are the input ports or the clock pins of the sequential element, and the output ports or the data pins of the sequential cells. In addition, one can further target a particular path using -through switch. So this is one of the switch that we use along with set false path. So finally, set false path in simple terms. So it simply specifies paths that are not real, which implies that these paths are not checked in the static timing analysis. So whenever you are setting one of the path as false path, then those paths are not checked in STA. So let us try to understand these by means of example. So this is one of the example which is combinational false path, which is having two multiplexers, and this is one of the combo logic. And here this is inverter, which is having port A followed by port B. Here you can consider A as input, B as output. So see here paths can exist either from A through multiplexer 1 A pin and again through multiplexer 2 B pin, and it is going to B. So this is happening when selection line of multiplexer 1 is 0. So simply if you are taking 0 here, then A will get selected. So the data which is present at port A will come through A to the output. Now when you are applying selection line as 0 here, that 0 after going through the NOT gate, it will become 1. So here 1 means in multiplexer this B pin will get selected. So the output which came out of this mux1 will go through the B pin and it is going to the output. So that's why this is the path which I have indicated with the red color. So from A through multiplexer 1 it is entering into the A pin and it is going through multiplexer 2 B pin and finally going to the port B. So this is happening when you are applying selection line as 0. So whenever this point the selection line is 0 here it is becoming 1. So this is one of the path. Now let us see what will happen if I apply 1 as selection line. So if I apply 1 here after passing through the inverter, it will become 0 here. So if selection line is equal to 1, the data which is present at this pin will get entered through the B pin of multiplexer 1, and through this combinational path it will go through mux2 A pin and is going to the output. So that's what I have mentioned here. Here paths can exist either from mux1B, so mux1B, and going through mux2A, this is mux2A, and finally going to the port B. So this is happening when selection line is equal to 1, means selection line for mux1 is equal to 1, whereas this is for selection line is equal to 0. So here there exist two paths, that is the red colored one is when selection line is equal to 0, and this green colored path is the one when selection line is equal to 1. So these are the paths which will be present depending upon the selection line. Now let us see what are the false paths. So you can see it here, there won't be any path from A again going through A to the output, and there won't be a path from B pin of mux1 going through combo and again through mux2 of B and going through the output. So these are the two paths that won't exist. Why? Because whenever selection line is equal to 0, we have seen here, whenever selection line is equal to 0, this red colored path exists. Whenever selection line is equal to 1, this green path exists. Whereas there won't exist a direct path from A to B and from B to B to B. So these are the two parts that won't be present. From A to A and is going to B, and from B through B it is going to B. So these are the parts which does not exist because of the presence of this inverter. So you can see it here. So from port A, mux 1A, so mux 1A, mux 2A, this is mux 2A, and going through B. So this path does not exist. And similarly mux 1B, this is mux 2B and going through B. These are the parts that does not exist. So finally within this figure, this is the actual path that will be present. This is the actual path that will be present depending upon the selection line. Whereas these are the two parts that won't be present. So that's why we need to mention these two parts as false paths. So you can see it here finally. A red colored one exists and this green colored one exists. So here this red colored path exists when selection line is equal to 0 and green colored path exists whenever selection line is equal to 1. Whereas these two parts does not exist. That is from A to B and from B to B. So these two parts does not exist, which I have mentioned it here. So from port A through mux 1A through mux 2B it is going to B. So this path exists. And one more thing, mux 1B through mux 2A through B, this path exists. Whereas these two parts does not exist. So out of the four parts, only two parts exist when selection line is equal to 0 or 1. So when selection line is equal to 0, this red colored one exists, and when selection line is equal to 1, this green colored one exists. The remaining two parts does not exist, so they should be treated as false path. Now these two should be treated as false paths. So for this one, we need to write the constraint. So you can see it here. You can write it in this manner. So set false path hyphen from. So from, this is a port. So that's why get port. Port name is A. And again through, it is going through mux 1A. So that's why through, and here it is a pin. This is a port. This is a pin. So that's why hyphen through get pins. Mux 1 is the instance name and is A pin. And again next it is going through mux 2A. So hyphen through get pins mux 2A and finally it is going to port B. So that's why hyphen 2 get ports B. So set false path from port A through mux 1A through mux 2A it is going through port B. Next set false path hyphen through get pins mux 1A hyphen through get pins mux 2A. In this manner also you can give. Either first one you can follow or the second one you can follow. If you see this first one, it looks appropriate according to our figure. Similarly, you have to write for this B also. So set false path hyphen through. So here hyphen through get pins mux 1B and hyphen through get pins mux 2B and hyphen 2 finally get ports B. If not, simply you can give it as hyphen through. So through B1 and through B of mux 2. So B1 is nothing but simply I am telling it as mux 1. So mux 1B, mux 2B. So that's what I've given it here. Set false path hyphen through get pins mux 1B, mux 2B. In this manner you can give, or else better follow the diagram. So in the first one you can follow the first case, and in the second one you can follow this first case. So these two are appropriate. So whichever you are comfortable in that manner you have to use it. Now let us see one more example. This is another example which I have taken. It contains like two flops and two combo logic. The output of this combo logic is connected to 2:1 multiplexer. This output is going through combo and it is again connected to 2:1 multiplexer and finally going through flop. And here one flop through which selection line is getting connected and it is getting inverted and connected to one more multiplexer. Now when selection line is equal to 0 means here selection line is equal to 0. If it is 0 here it will become 1. So here if it is 0, this C pin of multiplexer will get selected. If it is 1 here, this F pin of multiplexer will get selected. So that's why there exists a path from A, C, F, G. So A, C, F, G. This is the one when selection line is equal to 0. Means here if selection line is equal to 0. When selection line is equal to 1 means when selection line is equal to 1 here, after passing through inverter, here it will become 0. So there exists a path from B, D, E, G. So from B, it will enter through pin of multiplexer which is the D and it is going to E and finally going to G. So these are the two cases which I have mentioned. So there exists two parts when selection line is equal to 0, selection line is equal to 1. when selection line is equal to 0, there exists a path as shown here ACFG, which is ACFG, red colored one, whereas when selection line is equal to 1, this green colored path exists, that is B, D, E and G. So these are the two cases which exist when selection line is equal to 0 and 1. Now let us see what are the paths that should be declared as false paths. So you can see here there won't exist a direct path from A, C, E, G, and one more thing is B, D, F, G. Why? Because of the presence of this inverter, here whenever you are giving 0, here it will become 1. Here if you are giving 1, here it will become 0. So that's why these two should be declared as false paths. So finally, this is the final diagram. When selection line is equal to 0, ACFG path exists, means this red colored one. When selection line is equal to 1, B, D, E, G exists, which is green colored one. Whereas the path which I have indicated with this pink does not exist. That is AC, EG does not exist, B, D, FG does not exist. So these two should be declared as false path. Now for this two, we have to write the constraint. So consider the circuit below. The select line of the two multiplexer is complement of each other. STA tool, however, does not understand this logic and would treat all nodes as either 0 or 1. So in practice, there can never be a timing path between C, E, G and D, F, G. So which I have shown you in the previous diagram, and this can be marked as false path. So this pink colored one, that is A, C, E, G. So which is A, C, E, G is first one. Next one is B, D, F, G. So B, D, F, G. This should be treated as false path. So for this we are writing constraint. Here 3 flops are there, F1, F2, F3, and this is one more, FF4. And two multiplexers, I am giving instance name as mux1 and mux2. Now let us see how to write false path for this pink colored parts. So set false path. So through, it is going through mux1C. So that's why through mux1C. And next it is going through mux2E. Mux2E. And finally it is going through flip-flop 4G. Through flip-flop 4G. Next, this colored one. Set false path hyphen through mux1 D pin, hyphen through mux2 F pin, and hyphen through flip-flop 4G. So that's what I've given it here. So these two parts are false path. Let us see one more example. So this is one of the figure. Now here inverter is not present. So whenever you are giving selection line as 0 here, the same thing will get applied here. So that's why this red colored path exists. Whenever you are giving selection line as 1, here also it will be 1. So that's why this green colored path exists, means the data entered from input 2, it will go to Y1, it will go through input 4, and it will go through output, which is Y2. So that's what I've mentioned it here. If selection line is equal to 0, path 1 will work. Path 1 means this one, input 1, from input 1, Y1, input 3 and Y2. This is path 1 when selection line is equal to 0. When selection line is equal to 1, this is input 2, Y1, input 4, Y2. This is a path. So these two will be present. Whereas this highlighted one with light yellow and this light pink does not exist. But path 3 and path 4 are physically exist in the circuit but logically inactive. They are physically present but logically inactive. So they have to be set as false path by using set false path command. So here see it. This is input IN1 going through mux1 0, Y1. This is mux2 input 4 and Y2. So this should be written as false path. So that's what I have mentioned here. Input 1, Y1, input 4 and Y2. So this is one of the false path. And this pink colored one, input 2, Y1. So input 2, Y1, input 3, Y2, input 3, Y2. This is one of the false path. So it should be declared by using the command set false path hyphen through get pins. So mux1 is the instance name and input 1 is the pin name, that is for 0. And next hyphen through mux2 input 4, mux2 input 4. Next, coming to this pink colored one, set false path hyphen through get pins mux1 input 2, so mux1 input 2 and hyphen through mux2 input 3, mux2 input 3. Remember here these are pins, so that's why I'm writing here as get pins. So this is one of the example. So depending upon these situations, you have to write false path in your Synopsys Design Constraints file. So in this video, we have understood what is meant by false path and how to write set false path constraints for some of the examples I have shown it here. Thank you.